Hey everybody, it's me Ricky back again. We're starting a new activity now, hopefully like the videos with me or the previous activity. And we're starting an object tracker activity. This is part one of 3 parts. And before we dive into this tracker activity, I just want to talk a little bit about trackers and its importance. Later in the exercise, we'll go through the object tracking that the object tracking software that we'll be using for this exercise that led to this publishing of this paper created by the STEMcoding team. But before I dive in deep into this, just kind of want to talk about the reason for trackers. And so, there's a lot of physics that you can learn from just analyzing some object moving in a space if you got a video of it. And thus, just wanting to answer these interesting physics questions led to the creation of a lot of these trackers. So this is one of the trackers that are available for free online and have been around for a very long time. There's downloadable software versions here. I'm in the way for almost all OSs, but you will see there's no Chrome OS. And currently in the education system, Chromebooks is what a lot of public schools are using, and thus we want to be more accessible. So they tracker this one that's been around for a while made this I believe during the time of the pandemic to kind of help public schools be able to use this tracker online. The tracker online might be a little intensive for the Chromebook and be a little bit difficult to use and kind of understand. And so we wanted to make one that isn't as, so the team wanted to make one that isn't as intensive and be able to be accessible by anyone on any computer, regardless of the operating system that it's running on. So here's an example. This isn't unique to just this tracker, but just imagine you got a rolly cart, a cart that's rolling, and it goes down this hill, and then it hits a spring here. So you would assume then it would just bounce back up and down. And then the part that the tracker is tracking is this part here of the cart where my finger is. And it could generate this plot here where it generates its position over time, and you can see clearly there's bounces happening as you move along. And then as well, you can see it's slowing down, so when it bounces back, it's not going as far. So there's things you can answer. You can see, how much energy is it losing after every bounce, or you can figure out, how much did it deaccelerate after every bounce, things like that. And you could do that all by just using a tracker. The reason why it's useful is because with the tracker, this is an example here, but just in general, a tracker, you're right, you follow an object as it moves with time, and that gives you distance over time. And through that, you're able to calculate interesting quantities. You can figure out how fast it's going, what's its change in its velocity, how much is it accelerating. And then once you calculate those quantities, you could calculate things like kinetic energy. In this example here, you could calculate potential energy, like if it was dropped from the top. There's a lot of questions there's a lot of interesting physics questions you can ask and be able to answer just by getting distance over time. And so that's the value in a tracker. So you can able to figure this out yourself. Moving back here to the published paper that STEMcoding team got. Here in this picture is a more somewhat like real life example. And this is using the tracker software, not the online browser, but the tracker software from before. And they're tracking a red piece of tape on this individual here that's on this shirt. And it's in a very interesting space. There's a lot happening here. You got these windows. It's like a building, different colors. You got bushes. You got shadows. So, this is pretty intensive. And the back end of that tracker, it eats up memory, makes things potentially be slow depending on what kind of computer you have, and thus making things complicated. And one thing about trackers, if you really want to help them out, it's not unique to the STEMcoding one. It's just with any tracker out there. The object that you want to throw, or that's in the air, or that you're interested in, like getting the underlying interesting physics about it, is have a solid background. Something that's solid white, solid black, solid green. Here's another image of the tracker that the STEMcoding team made. We'll talk more about how this one works later on when we dive into it, but in essence, it makes it a lot easier for the system to differentiate what is background versus what's object, since there's very limited other objects or things in the frame. Another cool thing about all these tracker tools is that you can give them any video you want. And so we're fortunate now that we all got phones in our pockets. We could throw a ball in the air, record it on our phones, and we could put it into these tracker systems and then, analyze how fast it was going and all these other interesting physics questions. And so nowadays as well, a lot of phones, they have a slow-mo mode or whatever variation of slow, they got it. And in particular, on my phone, I have an iPhone. Their slow-mo mode is 240 frames per second. They also have a 120 frames per second option. They have a 60 frame per second option, 30, and then 24. However, the more frames you can get, the better, because of 240 frames per second, that lets you know the position of your object every 240th seconds. That's really small, or 1/20th or 60th, whichever. And so this is a really nice luxury that we have, so we can do more precise, more accurate physics. If you did use like the 30 frames per second, I'm sure you'll still get a good calculation, but just it won't be perfect. The more in science, the more precise, the better, to help minimize any error that you might get. So we're back in our activity page, and just one thing to note before we go and open the program is that the tracker program works best on Chrome and on Microsoft Edge. Fortunately, with Firefox and Safari, there's just some weird issues that happen that may not let the program work. And so you will need to have Chrome or Microsoft Edge to make the program work its best. So here, let's open up the program. And then I'll open up here. And then to get it started, just hit the play button or the start button. And then it should pop up here. So we'll talk about this part here, but this is if you want to put your own video. We could talk a little bit about this later or in a different video. So here's the video we'll be working with. It's either a basketball or a red ball just being thrown with a black background. So a nice clean setup, as I mentioned earlier, to help the tracker track the object, which would be the ball. And so with when we track the object, we're going to get its distance over time, and something that we want to figure out, that is the reason for this activity, is we want to figure out what its acceleration is, and then be able to figure out what's its initial velocity, final velocity, things like that. So here we go to, you just hit the analyze this video. So let's go ahead and analyze this video. So it opens a big screen here. And so now we have, there's at the bottom here is a scroll bar to go frame by frame for the video. Here, that's what this does. And so currently what's set up here is this green barrier, or let's call it this barrier, is for where the object tracker will be looking into, and of where we know the object will be. However, something to note is that, we want to make sure to try to just only have the ball in frame. So, maybe if I move forward in time, I guess maybe not too much, but the individual who threw the ball, their hands might be in the frame, and it could confuse the tracker. So, maybe you want to move that one of the green borders. So to figure out how to do that, on the top left here, we have info, and to move the green rectangle, you use the W key to move the lower left corner here, and then you use the E key to move this corner right here. And so to do it, you put with your cursor here, put it where you think you want that corner to be, and then you press W, and you could kind of, you know, if you want to play around with it or something. Whoa. But, you know, trying to get good data here. So maybe somewhere right there. And just for fun, we'll move this corner too, just because we could do that. You know, it took a lot of work to program this in. There you go. And just to double check, you know, nice. The object is in frame. Everything looks good. As well, something to note as part of this software too is down here you see this white rectangle. We have it above a meter stick that's on the ground in the video. That's just used for scale. So when we go to calculating later, we can actually say this, you know, we could translate where the object is, which is in pixels, because we're going frame by frame, and translate that to an actual unit of measurement. And in this case, we use a meter stick for reference. So if later on you do make your own video to put on here, you know, make sure you have a ruler or a meter stick for scale. Yeah, and then you hit the thing at the top. Might be hard for y'all to read, but you just hit that there, and it'll move to the next steps. And so now it says to identify the object that's in the frame. Pick. And so you have two options to pick the color of the object and the color of the background. So you can manually select the color, or you can use this click to choose color option here. So now we want to click 3 points on our object, and we know it's this red ball here. So make sure not to click the same 3 points. So just vary around the ball a little bit. And then now 3 points on the background, and same thing, don't just click 1 point, you know, touch around, and then nice. And so now the tracker was able to find, you know, where our object is and its difference between the background. All right, so you can see that the tracker did find our object. However, it also mistaked part of our background as the object, which is kind of interesting, but it's due to just how for this color distance mode, how this method works. And so if we think about a pixel on a computer, its color is based on something called an RGB value. It tells you how red is it, how blue is it, and how green is it. And this has an actual quantity from 0 to none of that color stuff was red, and there's 0, there's no red, or 255, meaning it has, you know, maximum red, and then the same for green and blue. And so if you imagine that, you know, we could kind of see this as a coordinate system, right? X, Y, and a Z. And if we, you know, we want to know for every pixel in this frame, you know, how is it our object or is it the background? One could ask a question of like, okay, let's take this pixel. It's going to have some values for R, G, and B. And we're just going to, you know, measure how far is it from the color of the object that we selected, which is red, versus how far it is for the background, which is black. And that's how it finds the object. And so an issue that we have here is that you can see that it's not perfectly black background. We have shades of black. We got gray. And so these white pixels here that it believes to be the object just so happen to be gray pixels, but these gray pixels their RGB values are such that it actually thinks it's closer to our red object than it is to our background, which, you know, the black space. And that's why it highlighted all these white pixels here in our background, thinking that it is our red ball. And so to fix that, there was a new mode, or there's a mode that the STEMcoding team made, and hopefully it fixes it. Let's find out. Awesome, they're all gone. So this is called brightness agnostic mode, and this is not at all religiously affiliated. It's just to reference that through some math, we removed the fact that brightness played a role. And so what we mean by that is that brightness is the reason why some of these from the black background in our image appear to be grayer. And so, we took that out of the equation, and now it's just able to ask, like, imagine we had a dark gray pixel, and then it just asked the question of, is this dark gray such that it's more black, or is it dark gray such that it's actually red? In essence, this kind of removes the brightness factor. It's just saying, is it the red, or is it the background? Is it black? And that's how the brightness agnostic mode works. All right, so we've gone over the different modes. One of the unique features of this STEMcoding made tracker. Before we track the object, which we would hit this button, there's another option for the color selecting part called manual color select. Instead of doing what we did before, where we click 3 points on the object and then 3 points on the background, we can just pick the colors that we say is the object and is the background. So let me talk a little more about this. So go ahead and click manual color select, and above here it says click on the bar below to select the color of the object. And so currently it's set up automatically, so it just shows pure red. But if you want to change it, go ahead and just click anywhere on the red bar, and here you'll get kind of a color palette, and you could mess with it. Let's get like blue. Pretty cool to pick the object, but let's just go to red. So we'll pick red, and then we'll just click up here when we're done, and then same thing with the background. So in this case, we know the video, we know it's a black background, but to make it easy on us, we'll just say it's pure black. And so now the methods that the modes that we talked about, they still work, but now it's looking at these RGB values that we're giving it when we select. So we're clicking pure black, and we're doing that value 000, and we do pure red, it's 255 for red, and everything else is 0. And so the modes still function as they do, but now it's a little easier in a sense that what is the closest thing to this pure red, then we say that's the object, and then what's the closest thing to this pure black, and then there'll be our background. And you can see it works in both modes, and this might be just useful in the sense of maybe you clicking on the colors wasn't working well for you, or maybe it's just easier. Maybe you don't want to do the headache of clicking 3 points, but this is another alternative, and it works really well. One thing else to note is that, say later on when you make, maybe you want to make your own video and track it, and you like the manual color select mode. So let's say your background was white and you had a blue ball, but you don't want to keep hitting play on this tracker thing to get it, and then go through color select, and you go here and you go here and you get the blue, and you go click this and you want white. It gets kind of tedious, but looks like I messed up the program, but we'll get to it. But so say you had a white background and you had a blue ball object, and you keep running this, but you're tired of hitting the manual color select. So y'all know how to code. You're pretty far into STEMcode, so you should know a little bit about how to code, hopefully. And down here in the program, we initialize what it is when you first click that mode. And so it's set up so that it's red and then it's black. But you could change that yourself. So if you wanted it blue, let's just say pure blue, we would go in, red 0, and then it's RGB. The middle one's green, and then the farmost right one is blue. You just put 255. And then for white is just all the colors maxed out. So if you wanted to, just type it in, and we'll see if I actually know how to code. Let's just run this, and we'll see. Ideally, it should be changed. We'll hit analyze this video again. This is fine. Boom. So now, this is, just imagine there's a white background here with a blue ball, but now the manual select is blue. It's white. Let's just see what happens for fun. This is not good for this video, but if you made your own that actually had the setup, it would work well. All right, now we're on to the fun part. So now we're gonna actually track our object. So, you made it this far, you've, did manual color select, all the modes, you tried them all out. Now you actually want to do some cool science, get some data. So just go ahead and track my object. And you can see we're going frame by frame here. And it's able to track the ball as it moves. And the nice thing is 240 frames per second. So we're getting nice and slow. We're getting every position over time. And it's following, basically this red pixel here that it's following is the center of it, of the center of all the pixels surrounding, which this also tells the nice thing is should be the center of mass. All right, so something may or may not pop up your screen, but depending on your browser, you should see that a new download came, and it should be called data.csv. In my case, as a 4, but that's because, I did many takes. It's not my fault, it's hard. But you might have a bunch too, maybe you download a bunch of times, but you should be able to see in your recent downloads, or you might need to go to your file explorer if you're confused, but you should be able to find it. And now there's going to be a little cut here. We're going to move to a spreadsheet where we're going to open this, and we'll see what exactly was recorded by our tracker. All right, we're going to use Google Sheets for this exercise. You could probably use Excel or LibreOffice or any other sheet, but we're going to use Google Sheets here, and just so it can be step by step. We're already logged into our Google account here, but you might need to log in, but we're just going to go Google Sheets. We're going to hit this one here, and Google's nice enough that it just opens up an empty sheet. And so we need first step is to upload our file so that then we can access the data. So we're going to go open. We're going to go upload and browse, and then most likely where your data.csv file is in the downloads folder that you have on your computer. And then something that might help is modified or made by, if you're like us, we got a bajillion downloads, and it's kind of a lost cause sometimes, but this is the newest thing here, right? We just started. Upload this. Double click, enter, and then boom, we got our data. It's up on Google Sheets, and now we could utilize Google Sheets to analyze this data that we got. So now let's just go through what was recorded and what's going on. So I'm just gonna extend these here just so we can read everything. And so the tracker recorded time because it has frames per second. It's able to figure out the very first frame is time 0, and then as it progresses, it tracks time. And then the tracker part is getting the distance in X, so horizontal, and then in Y, so vertical. And so X and Y. So you might be asking, what's this object out of range ? So if you remember earlier, I should still have it up here, these green bars. So this is where it was keeping track of everything within this border, within this barrier. And so for a few frames before, our object's never in that, and so the tracker's, it makes a good guess, which is the right guess. It's out of range. It's not within the borders, this green border that we had. And so it just says out of range, which is good. We don't, that's how we set up our tracker. And we just scroll down a bit, you'll finally get some data. You'll get positions. We'll get X and Y coordinates, which is pretty neat. So we could just go all the way down. We see its position in Y, its position X over time. Pretty neat, pretty cool data. Lots to figure out here.